Hi folks, we're going to take a look at an example of finding the intervals of increase and decrease for a function. So here we've got this function y equals x squared times e to the x, and recall that we found that when the derivative of a function was positive on an interval, then that function was increasing, and when the derivative on an interval is negative, then the function is decreasing. So our goal here is to determine when the derivative of this function is positive and negative. Okay, so let's start by determining the derivative. So y prime is equal to, well, here we're going to have to use the product rule. So here, derivative of the first function is 2x times the second function, e to the x, plus first function, x squared, times the derivative of the second function, again, is just e to the x. Now, we want to determine when this function here is positive and negative, and of course we have to look for those points where the sign can possibly change, and those can happen at x-intercepts and discontinuities. Now, we don't have to worry about discontinuities here because a function like this is not going to is defined everywhere, so it won't have any vertical asymptotes, but we then have to determine when it's equal to 0. Okay, so I'm going to set the derivative equal to 0, and here I'm going to see if I can do some factoring. So it looks like they both have a factor of x, and they both have a factor of e to the x. So I'll factor those out, x, e to the x, and let's see what we're left with. We're left with just 2 from the first expression, and then from the second expression, we're just left with an x. And so now that we have it in factored form, this is very easy to solve. Okay, so what are our possibilities? Well, we could have x being equal to 0. We could have the second expression, e to the x equals 0, or we could have the third factor, 2 plus x equals 0. So here, well, already solved for us. Here we realize that e to the x is an exponential function. It's never equal to 0, so not applicable. No answers coming from here, and then here x can be equal to -2. So the zeros of the derivative are the only places where the derivative may change sign. Okay, there's no guarantee that it will change sign at those points, and so this is where we have to test this out. So I'm going to test out the sign of y prime, and the only places it can change sign are at -2 and at 0. And of course we know that since these are the only places it can change sign, I just have to test one value in each of those intervals. So if I test -3, now remember I'm testing the sign of the derivative, not the original function, so I need to put this into the derivative function, and I'll put it into the factored form, because here I have -3, that's going to make this negative, e to the x is always positive, so I have negative times, and 2 plus -3, that's going to be negative, so negative times a positive, it's going to result in a positive number. If I put in -1, so again, recall e to the x is always positive, so I don't need to worry about that one. This is going to be -1 times 2 minus 1 is 1, positive, negative times positive, going to be negative in this interval. And then if I pick, say, 1, well, positive times positive is just going to be positive. Okay, so according to our results here, we can say that this function is increasing on, well, the interval from -infinity to -2, and then the interval from 0 to positive infinity. Okay, because these are the intervals where the derivative is positive, and then it's just going to be decreasing on whatever interval the derivative is negative, which is just going to be from -2 to 0. Okay. And so notice here we were able to determine this just by working with the sign of the first derivative. Okay, if we just want to check that this is indeed correct, I've got this graphed here. So if we take a look at this graph of, just so that you see, x squared e to the x, okay, here we see that it's increasing all the way up to -2, then it's decreasing from -2 to 0, and then from 0 onward it is increasing, just as we anticipated. Okay, so again, just to recap, when you're looking for the intervals of increase and decrease, it's about determining the sign of the first derivative. So once you found the first derivative, you just determine the sign, just as we would have done in the previous course. Look for the places where it can possibly change sign, and then test the intervals produced by those numbers. All right, that's it for this one.